Manufacturing industry is right in the middle of a digital transformation. Making use of big sets of machine data for making fact-based decisions in maintenance and improvement work is a cornerstone of industrial digitalization. Therefore, this type of project, combining computer science knowledge and manufacturing domain knowledge, is very important for future competitiveness. In this project, we help production and maintenance engineers to find time for improvements and repairs without stopping production. We call it maintenance opportunity windows.
In this project, we are going to use the machine states as an information, and these machine states are monitored across a production time. And we are going to represent this in a graph. We see that this is the production time, and we see that this is the machine axis. And we see that these are the machine states. And as you see, the machine states take two states. One is the active, the other one is the not active. Active state is represented by a line, and the not active state is not represented by a line. And these active and not active states gets populated across a production run. And assume that we are at a time t here. And we would like to predict what will happen to these machine states for the next 10 minutes. And we are going to press a button that can predict, that can do the magic of prediction of what will happen to these machines for the next 10 minutes. And you see that the machine states gets populated. And we also see that the machine 1 has an opportunity window. That means that the machine is going to be idle for the next 10 minutes. Wow, that's a good opportunity for maintenance team to do some minor activities like burr cleaning, like screws, like screwing techniques and other things to do within this 10 minutes. And these activities can be done without affecting the production flow. In order to predict the opportunities windows, we designed two different modeling approaches. The first one is called the uni-machine model. The second one is called the multi-machine model. In the uni-machine model, we predict the opportunities windows of a machine based on its own historical data. Whereas in the multi-machine model, we predict the opportunities windows of a machine based on own historical data plus the historical data from other machines. Under these two models, we designed three different algorithms to predict the opportunities windows. The first one is called the neural networks, the second one is called the decision tree, the third one is called the balanced bagging. Under each of these algorithms, we designed 5 different window sizes. One is 10 minutes, the other one is 15 minutes, 30 minutes, 45 minutes, and 60 minutes. The results show that the multi-machine model was performing much better than the uni-machine model. And we see that the decision trees algorithm is much better algorithm than the neural networks and the balanced bagging. We see there are different varying window sizes across different machines. We don't want to make a trade-off for the window size at the machine level because we need to trade off with a larger precision accuracy. Means we need to give off a larger precision accuracy. Therefore, we have varying window sizes for each machine, but with the decision tree under the multi-machine approach. This is our result.
So think about the impact of this project. If we could do maintenance of a car factory without stopping the production of cars, we could save a lot of money for Swedish industry. So once again, this project is a great example of cross-disciplinary research bringing value, real value to Swedish industry. A great example of industrial digitalization.